Hi everyone, I'm Simon and I'm going to be talking about Faabric, stateful serverless functions with shared memory and message passing. So if we look at the Venn diagram of serverless today, we've got parallel computing in practice, i.e. this huge green blob on the right, and then actual serverless on the left. So the parallel computing in practice zone contains all the existing code in all of these important domains here. Serverless, kind of limited appeal, it's just embarrassingly parallel workloads. Some things do fall in this tiny gap, but they take quite a lot of effort to create academic systems, custom ports of existing libraries, etc. So we believe the problem here is the dominant single programming model for serverless, which is stateless ephemeral functions. So this isn't particularly useful to parallel programming. Stateless, kind of goes without saying, parallel applications generally need some state. Ephemeral means that functions can't pass messages between each other. We also can't guarantee them a level of parallelism. And then functions. This word in serverless has kind of become meaningless. It's provider specific, and really things need thread and process semantics. However, these are incredibly useful for providers, and we don't want to lose the benefits that they convey. So our solution is Faabric. This adds threads and processes, shared memory, message passing, and we believe that it's provider friendly. So it does all of this transparently via existing APIs like OpenMP and MPI. All the details for this will be coming out in a paper in a couple of months, so you'll have to wait for those. We're going to demo running LAMMPS today on Faabric. LAMMPS is an incredibly popular molecular dynamics simulator, runs on lots of existing HPC environments. And here we're executing unmodified code on Faabric integrated with Knative on Azure. Okay, so this is the experimental setup. Here we can see 3 terminal windows, a couple of them on the right, open on the client machine. On the left is just the K9's interface to our Kubernetes cluster. So on the right, we've uploaded the pre-compiled WebAssembly code, LAMMPS compiled to WebAssembly, along with the associated data. Now we are invoking the application on Faabric, specifying that we want to use 16 MPI processes. So what will happen there, you'll have the initial function, that'll fan out 15 more. And then Faabric will handle all the scheduling and execution. It will also handle the delivering of the messages between the functions via the Faabric implementation of MPI. On the left, you can see the standard output of LAMMPS. This would be the same if you were running it on a native machine. In the paper itself, we'll be comparing the performance of this to native MPI implementation. And you can see there it took 24 seconds to run this. Again, a load of output from LAMMPS talking about the timings and stuff. Now, what we can do once we've finished the execution of our function is query for the execution graph. Sorry, here we're just showing the nodes that it executed on, 4 nodes with 4 cores each. And this execution graph should show us that Faabric has decided to distribute our 16 MPI processes evenly across the hosts. And also we'll get an MPI specific graph which will show us the messaging topology and how the messages have been distributed. The reason that's interesting is that Faabric actually uses this topology to migrate functions and do runtime co-location to minimize cross-host messaging. So anyway, here we've just downloaded the execution graph. All this metadata is available by default in Faabric. And these are the functions that were executed, colored by the host on which they're executed. So we see orange, green, blue, and pink. And indeed, those 16 MPI processes were executed over different hosts. All of them, you see, took about 24 seconds, which is to be expected. And then here we're just copying down the MPI specific graph, which will show us that this application uses a Cartesian topology, i.e. a sort of square. And it's sending 186,000 messages between all the different nodes. And the messaging itself is all handled by Faabric, as is the migration via the topology. So all of this is transparent. Yeah, more details for that will be in the paper as well. And yeah, that's it. Thanks for listening.